Hello students, Stride here. Hey, we start into chapter 16, section 1, titled Electric Charge. As we complete this section, you will need to understand the basic properties of electric charge. You need to be able to differentiate between conductors and insulators and distinguish between charging by contact, charging by induction, and charging by polarization. In today's lesson, we're going to look just at the basic properties of electric charge. If you run your hair or comb through your hair, a plastic comb, you might notice that the comb attracts your hair, or it might attract small pieces of paper. As you go through this little video, write down in your notebook any notes that seem to be pertinent, and submit me a photo when we're done. So, very simple little experiment is just taking and rubbing a balloon on your hair. And then that's going to be attracted to your hair. That same balloon, if it's on a dry day, will stick to a wall. All this is because we have electrically charged objects. At a dry day, because moisture in the air can provide a pathway to leak off the charge. If you rub your shoes on a wool rug, sliding across the car seat, you're going to get an electric charge in your body. And that charge can be removed by touching another person. And if you look closely, you might even see a spark just before the touch. Or you'll also feel a little tingle. If you rub two balloons across your hair and then hold them near one another, they will repel, as illustrated here. So, why does this happen? It's because they have the same kind of charge. And one of our key ideas here, like charges repel. Make sure that one's written down. And likewise, if they don't have the same kind of charge, they're attracted to each other, thus unlike charges attract. Another key little point. Ben Franklin named these two kinds of charges positive and negative. When we talked about the balloon in your hair, the charge on your hair is positive and the charge on the balloon is negative. These are said to be opposite charges because if they have an equal amount of positive and negative charge, it has no net charge. So another very key idea. A little example of all this involves electrostatic painting. Give the paint droplets a negative charge. give the object to be painted a positive charge, and the negatively charged droplets attracted to the positively charged. So with this attraction, less paint is wasted, as said up here. If we're not using electrostatic, then it will just drift off out and away, be wasted. So, two kinds of electric charges, positive and negative. Just summarizing some of the key ideas. Two kinds of electric charge, positive, negative, and like charges repel, and unlike charges attract. So, how does all this happen? How do the balloon and your hair become electrically charged? So we look a little deeper into matter. So, some review stuff from chemistry, physical science. Every atom made up of even smaller particles. We've got protons and neutrons. Protons being positively charged, neutrons being uncharged or neutral. Located in the center of the atom, called the nucleus. And we got negatively charged particles, called the electrons, outside the nucleus and move around it. So, a lot of key information here. So, protons and neutrons, pretty well fixed in location, fixed in the nucleus. Electrons, though, easily transferred from one atom to another. So if the electrons are balanced by protons, we got no net charge. That's what happens in a normal atom. Neutral atom, equal number of protons and electrons. However, if we transfer electron from one atom to another, second atom is going to gain a negative charge. First atom loses negative charge, making it positive. Now, these atoms that are positively or negatively charged are called ions. The balloon and your hair both have a large number of atoms. A large number of atoms. And charge has this tendency to be transferred between unlike materials. So when we rub two surfaces together, it increases the area of contact and enhances this charge transfer. When that balloon was rubbed against your hair, some of the hair's electrons are transferred to the balloon. So the balloon gets a little negative charge. Your hair loses that negative charge, ends up with a positive charge. But only a small portion of the available charge is transferred from one object to another. The positive charge on your hair is equal to negative charge on the balloon, which means electric charge is conserved, no charge is created or destroyed. There's another very key little idea. In this principle, conservation of charge, one of our very fundamental laws of nature. So, reviewing back over a little what we just dealt with here. Electric charge is conserved. Remember that positively charged particles are called protons, uncharged particles are called neutrons, negatively charged particles are called electrons. These are a few of the very key points that we just went over. Some of this information was developed by a scientist named Robert Milken back in 1909. Did a thing we call the oil drop experiment, where we had this device I have illustrated here. We got charge plates. Oil droplets charged by friction, and a little tiny hole in the top plate, and they're allowed to pass through. So, fell due to their weight, due to gravity. Top plate had a positive charge. The droplets with a negative charge were tracked back upward towards that positively charged plate. And after a lot of observations, turned the charge plate off and on, watched oil droplets for many hours. They rose and fell, did this for thousands of drops, and he found out that when this object was charged, its charge was always a fundamental charge, a multiple of a fundamental unit of charge, symbolized by the letter E. So we say charge is quantized. Charge occurs as integral multiples of E in nature, which means we have like plus or minus E, plus or minus 2E, plus or minus 3E. Very key information here. So other experiments done about this same time showed that the electron had a charge of minus E, and the proton had an equal and opposite charge of plus E. And the value of E determined to be 1.602, 176 times 10 negative 19 C, which is the Coulomb, SI unit of electric charge. For our calculations, we're going to use 1.60 times 10 negative 19th coulombs. So, very key idea right there. So that's E. So total charge of 1 coulomb, or negative 1 coulomb, contains 6.2 times 10 to the 18th electrons. And the number of free electrons in 1 cubic centimeter of copper is around 10 to the 23rd, so 1 coulomb is quite a bit of charge, dealing with lots of electrons. So electric charge is quantized. Object is charged. It's a fundamental unit charge. Charge measured in coulombs. And the fundamental unit of charge, the magnitude, charge of a single electron or proton, is this number, which again we're going to round to 1.602. So here's some of our key information of the last few things I talked about. So that's what we got for today. That's it. We'll see you next time.